Assalamualaikum and hi. First and foremost, we from Group 5 would like to present our project assignment part B, Instrument and Control, titled System in Plastic Bottle Filling and Capping. Hi, my name is Muhammad Azuma. I will explain about the problem description. The term automation emphasizes the automation of a typical process, which reduces human work and thus promotes productivity, which is required for accurate and fast production. Programmable Logic Controller (PLC) is the current instrumentation device as shown in the YouTube video. It is a computer-based device that controls equipment in an industrial facility. PLC can control a wide range of instruments. In PLC system, the PLC replaces the wiring between the device. Instead of being wired directly to each other, all equipment is wired to the PLC. The control program within the PLC then provides the wiring connection between the device. The control program is the computer program stored in the PLC memories that tells the PLC what is supposed to be happening in the system. The bottle filling and capping machine is a programmable system that allows the user to automate the filling process. All of these processes are controlled by a PLC. In this system, empty bottles are placed on the conveyor belt from one end and moved to the water nozzle powered by a water pump. The switching of this pump is controlled by a replay board, which determines the amount of time the pump must be active, thereby determining the water level in the bottle. The water has been filled and is transferred to rotating cylinder guided by a stepper motor. For cap mounting mechanism, a pneumatically actuated piston pushes the DC motor setup on the cap. The cap on the water bottle are tightened using rotational motion from a DC motor setup, and then transferred to the packaging box via the next conveyor belt. From the video, the automatic filling machine and bottle cap can be modified, and new processes can be added. The PLC is less effective at determining whether or not the bottle can be completely filled. As a result, new instrumentation devices or an appropriate sensor for the automatic bottle filling and capping machine are required to ensure that all bottles are completely filled in order to produce effective productivity.
My name is Muhammad Harid Amin bin Zailani. My matrix number is D0520100041. So today I will present for the new instrumentation device or sensor. So first, we have planned to put a new sensor, which is a position sensor. Position sensors are devices that can detect an object movement or determine its relative position to a specific reference point. This sensor can also be used to detect the presence or absence of an item, such as the bottle in this system. We use the position sensor to replace the metal bar that help to align the bottle to the center. Next, photodetector. We also added a new device in this system, which is a photodetector. Photodetector are sensors of light which may be classified by mechanism of detection such as a photoelectric. It also process of converting an optical signal into a signal of a different type. It can detect that there is a miscap bottle when the bottle stops at the position. The bottle may unseal if has no cap right on the bottle. So we have planned to put the photo detection to detect miscap bottle.
I will continue the session. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nofidaus bin Tahir. My metric number is D0520101140, and I will explain about the advantage of light sensor. The light sensor is the device that we put into the system. Light sensor is a sensor device used to send light. It is device that convert light input into corresponding electrical output. So the advantage of light sensor, number one, is it is easy to integrate with lighting system such as automatic lighting system. Number two, light sensors need small voltage and power for its operation. Number three, the photoresistors are lower in cost, bidirectional, and offer moderate response time. Number 4, photodiodes offer quick response time, lower in cost, and provide digital output. Number 5, photoresistors are very large and provide immediate output compared to photoresistor. Number 6, phototransistor generate high current compared to photodiode. Next, I will explain about the limitations of the light sensor. LDR, which is light dependent resistor, are highly inaccurate with high response time about 10 seconds or 100 of millisecond. Number 2, the resistance varies continuously analog in photoresistor and are rugged in nature. Number 3, the photodiode are temperature sensitive and are unidirectional unlike photoresistor. And lastly, phototransistor cannot withstand voltage above 100 volts. So that's all from me. Thank you very much.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Khairun Jauhari, and I will continue the explanation about problem solution. So our team took the photo detectors for a better machine. So photo detectors, often known as photosensors, are light or electromagnetic radiation sensors. Photo detectors are categorized according to their detecting mechanism, such as photoelectric or photochemical effects, or by other performance criteria such as spectrum response. The p-n junction in semiconductor-based photodetectors turns like photons in electricity. So this photosensor have three modes of operation. First, photovoltaic mode, also known as zero bias mode. This mode generates a voltage by using a lighted photodiode. It provides a very small dynamic range and non-linear requirement of the voltage form. Second, photoconductive mode. In this photoconductive mode, the photodiode is typically reverse biased. The application of reverse voltage widens the depletion layer, which reduces the response time and junction capacitance. This mode is overly fast and produces electronic noise. Third, avalanche diode mode. Avalanche diodes operate in a high reverse bias condition, allowing an avalanche breakdown to be multiplied to each photo-produced electron hole pair. This result is in an internal gain in the photodiode, gradually increasing device response. Okay, next, the sensor maintenance. In order for a manufacturing system to perform correctly, every tool and part must be well maintained, whether you use stock analyzer, load cell, or other measurement tool. It is vital to know how to handle and care of them. So this is 5 things that we need to take care of. Okay, the first thing is correct alignment. If one of the parts is not aligned properly, it is necessary to recalibrate and adjust it. To perform this successfully, you will need the right measuring instrument. Comparing one right instrument to the one you are repairing is all it takes to calibrate an instrument. Second, maintain it clean. So this one, it's also important to keep everything clean so that all of the moving parts can do their work properly. Ensure that all trash and grease are removed from the sensor at the end of the day. So the third, proper storage. When you are not using your tool, make sure it's properly stored depending on the size and placement of the tool. This could involve disassembling it until you need it again, leaving it on a stable surface, or recovering it with a top. Next, the corrosion. Excessive rusting can hasten the wear of a machine element. Consider hiring a professional or replacing the part totally if you are unable to eliminate corrosion on your own. Also, keep moisture away from the instrument as much as possible to avoid this from happening in the first place. And the last one, replace time. Remember that the sensor maintenance and cleaning will only get you so far. It's time to replace a tool if you find yourself realigning or repairing it more frequently than it was. Before you order a new model, double check the tool's warranty. So I think that's all from us. Thank you.